Okay, after we derive the quadratic formula, we can apply this to solve the quadratic equation. And you just need to match what A, what B, and what C are, and then you can figure out using the formula. See, example 1, you can compare the equation with the general one. You can easily figure out A, B, C, right? They just equal to the number. Just compare, right? A, B may be easier, but the C, be careful. If you look at the variable, it's just plus C. But here is actually, you can understand as plus -1. So that means the C equals -1. Okay, if you have ABC, just plug in, right? It's nothing tricky here except the C, be careful, it should be negative. But this subtraction, it has nothing to do with the negative. So eventually, if you multiply it here, you should get a positive. -4 multiply 1 and multiply negative, it should be positive here, so you got 4. So add it together, then in most of the cases, you're probably gonna have to get a radical, which is not a perfect square, right? It's a 20. So then just simplify this. You can change the 20 into 4 times 5, so the 4 can be take out, becomes 2, right? And then here you can factor the 2 out, then divide by 2, cancel with this 2. But you can also simply just use -4 divided by 2, and then the 2 square root 5 divided by 2, so you can get the same thing. Okay, look at the B. So B, you're getting if you compare, so here B is negative, C is positive, right? So then be careful when you plug in. So the B here, it's negative B, and then you put the negative here, and then this negative is one part of the formula, but this -1 is the B, so that's, be careful. Everything else should be pretty straightforward, except that when you get this, you get a square root of -15. It's undefined, and it's not a real number, right? So this is actually is called imaginary number. So then normally we see, oh, this equation has no real roots. Okay.